Hello, my name is Vojtech Miksu, and today I am going to talk about documentation. My job is building React component library called BaseWeb and other web tools at Uber. BaseWeb is an implementation of our design system, and we use it across all applications. So let's talk about documentation. It's something that most of us use every single day, and it's absolutely essential. Every day, we are sitting at our desks, trying to learn things by reading, and only sometimes we pause to write a few lines of code. And there are many different sources of documentation. We have books, MDN, Stack Overflow, comments in the code, or we just randomly Google things until we give up and Slack our colleagues. But what is my real motivation to talk about this today? I joined the company 2 years ago, and this was the proposition given to me. Join us, you'll be building React components. That sounded amazing, and I was immediately sold. However, the reality of platform-oriented work is slightly different. It looks more like this chart. And frankly, it's a good thing. If nobody uses your things, it means, if nobody asks you questions, it means nobody uses your stuff, and that would be awful. So you could say my team became a victim of its own success. When we started BaseWeb 2 years ago, it was barely used, and we had a lot of time to just write code. But then the usage spiked. There is now over 600 applications just in Uber. And that translates into almost like 1,000 developers. Also, our library has a giant API surface. There are over 60 components, hundreds of props, and pretty much endless possibilities. We also have a lot of outside contributors and users. So naturally, we spend a lot of time with support. The question was, can we reclaim some of this time back? I strongly believe that if we build an amazing documentation, we can significantly reduce the number of questions in our chats and GitHub issues. Also, we do frequent surveys, and documentation is always the most mentioned topic. So my team now invests a lot of time into experimenting with different kinds of documentation. Hopefully by now I made my case for why documentation is so important. Here's the agenda for the talk. I'll show you some older versions of our documentation website and explain why it wasn't good enough. Then what we built with React View and use today. I'm also going to peek under the hood and show you some concepts and code related to compilers and abstract syntax trees, and finally, conclusion. So this is the oldest version of our documentation. It's just Storybook. It's off-the-shelf solution. We used it to develop our components, but also to document them. You can see it's pretty much just a bunch of examples. And at the bottom, you can see README, where we document our props. But as we grew the number of components, we wanted to have something more structured and customized. So we launched our own custom website based on Next.js and MDX. Now components are in different categories. The page itself is more structured. Each example has its own source code that's manually written. And at the bottom, we have perp documentation generated based on static types. And this works reasonably well until it just doesn't. Some static types are just too complicated and not really human readable. Also, many props are meant to be used internally only when composed by other components, but now we expose them in the public API, and that's just confusing. We tried to tweak this many times, but it was never reliable and not sufficient as the primary source of documentation. Developers can always tell when something is auto-generated, and they will not exactly love it. Why should they put extra effort into reading it if you put zero effort into creating it? So how about adding a lot of examples? Who doesn't like more examples? This is our tech component. It's pretty simple, and yet there are 384 different permutations of it. Can we display 384 examples on a single page? Sure. Is it going to be overwhelming? Absolutely. And the same thing goes for other components. If there is a limited number of examples we can present to not overwhelm our users, what else we can do? Well, let them toggle and explore these permutations. Let me show what we built. So this is like a playground we built for our components. First of all, you want to display the component itself. The second most important part is probably the source code itself. A nice thing about the source code is you can edit it in real time. And as you type, it like changes the component. If you make a syntax error, we just tell you what's wrong. We also added this, this feature where you can hover over different components and see their static types. So this is a pretty common feature on a lot of documentations, but have you ever asked like how this actually works in your browser? There's a useful API for creating JavaScript functions from strings. The first argument are parameters of the new function, followed by the body. Unlike a val function, this is executed with a global scope only. So anything you want to pass and use in this function, you need to pass as an argument. So now we can dynamically execute any JavaScript from string, but what if we don't deal only with plain JavaScript? And actually, we almost never do. All of our components use JSX, and you probably saw what happens if you try to run JSX in your browser. You get this syntax error about unexpected token. We can't really ask people to type React Create element instead of JSX, so we need to introduce some extra step, some extra process. We need to add a compiler. Remember Babel? Most of us use it when we need to compile our applications. But we can also use it in our browser to compile our JSX into React Create element. We use transform function from Babel core. We load up React preset. We pass it our component, and it returns the React Create element call instead. So this works pretty good. So now we have the component, we have interactive source code. Then we also added some convenient functions. For example, developers like to format their code so it's more readable before they copy paste it. You can copy the code into clipboard. You can get a permanent link. You can get back into the initial state. And you can also spin up code sandbox and do even more serious editing if you wish. So this is great, but sometimes you don't even know what other props you can use for this component. So you need some sort of props API or props documentation. So we added this additional part we called knobs. So each prop is represented by a single knob, and you can also interact with it. So as I change this value, you can see it updates the component itself. But most importantly, it also updates the source code. So this state is synchronized across all these three parts. And it gets even better. For example, if I change this kind to secondary, you can see it even changed the import. So this is like something you can always copy paste into your application, and you get this exact component in this exact state. So not only I can interact with these snaps. I can also still change the source code itself, and you can see again it updates the state here. So this checkbox is now checked, and the component is in loading state. So how does this work? First of all, we need somehow describe what properties our button has, so we can render the knobs. We've created a simple configuration format. Here's the example. For each props, you can set name, the type, and description. And when we update the code, we now somehow need to extract some pieces of information out of it. We need the prop names and values so we can display them in our knobs. The first quick solution would be to use a regular expression like here. Here we are matching a JSX element and getting back the parts with props and children. It works, but it's extremely brittle. What if we have multiple components? What if they are nested? How to tell them each apart? Now the code is just a dumb one long string. We don't have some deeper understanding what it really represents. So we can't really do much about it. We need a completely different and more powerful approach. We need to turn our code into a tree, the abstract syntax tree. Fortunately, we already have a tool just for that in our project. It's Babel. In order for Babel to do anything with your code, it also needs this deeper insight into its meaning. So it always starts by creating an AST out of code you pass to it. You can inspect ASTs in this very useful tool called AST Explorer. So here is our button. We are using Babel Parser. And on the right side, you can see the tree representation of our code. Now, if I hover over different parts of our code, you can see like what node is like being highlighted. So for example, this button now corresponds to this JSX identifier. If I go over the type, you can see it's JSX attribute. And the primary is a string literal. So now I know exactly what each part of this code is, and I can just be sure I'm getting values I need to get. So here's the implementation. Like first, you use the parse function from Babel Parser, and you give it your code. And this actually generates the tree structure you saw. And then we use traverse function to walk this tree, and we are looking for all JSX attributes or props. And once we get this type of node, we just save the name and the value. So this is like very simple way how we can get all the prop names and values from our component. I also demonstrated we can do it in reverse. So I was able to change these snaps, and it was actually updating this code. And by the way, we've never written a single line of this code in our examples. Like this is all generated just based on the prop configuration and the state of this playground. So how this like process works in reverse? How do we actually generate a code? So as you can imagine, there is some sort of state with props where you have the list of the names and its values. You know what the name of component is. So again, we could try something simple, and we could just glue a bunch of strings together. And this will give us the final snippet, and it works. But again, it gets complicated pretty quickly with all the exceptions and different cases. And it's also a very easy way how to produce a code that doesn't work and has some syntax errors. We already learned similar lesson with regular expressions. And so again, we need a more reliable approach. I mentioned trees already. And it turns out we can also just build them from scratch. So this is a simplified example of function that creates an AST of JSX element. We can compose nodes together to build our own tree from nothing. Since all these functions are statically typed, if we are forgetting to pass any value, we will get an error. And now we can be sure that whatever is the final script is, it's going to work. So this is, of course, now we have the AST, but we still need to turn it into the code. So once we have the AST, we can use generate function from babel generator, and this just turns the AST into code. But there's one glitch. This will result only into single line of the code, which is not super readable. So we can get fancier, and we can use like other popular tool called Prettier. And Prettier is actually using the same AST representation for the code as Babel. So we can just use Prettier to print out much nicer code snippet. So there are many other features of this playground I don't have time to show you. For example, not all components are as simple as button. Sometimes you need to include sometimes you need to use local state to make your examples realistic. We support that. Sometimes you need to nest multiple components. We support that. Or you even want to build a custom prop type and a custom knob for it. We also support that. All this is wrapped in this library called React View. It's open source, and it has its own interactive documentation, so please check it out. And here are some final thoughts. First, documentation is immensely important and a critical part of anything you ship. It helps your customers to use your product, but do it also for your own selfish reasons. You can save yourself a lot of time by not answering questions that can be answered by quality documentation. Second, how can we make documentation much better? Get your superpowers with abstract syntax trees and tools like Babel and Prettier. We already use them to build our applications, but we can also use them to write some boring parts of our code and build much better documentation. And finally, to get started, check out React View. It's open source, and it covers all examples in my talk and our documentation. And there is one more thing. We found another use for having a prop specification for each component. We translate it into VS Code snippets. It's a great power user feature. Oftentimes, your developers don't even need to read documentation to produce new code. And what's better than that? If you want to keep up to date, here's my Twitter, and thank you for watching.